All right, guys, we are going to be learning how to solve quadratics. We're just starting with quadratic functions because I'm sure you all know how to solve a linear function to find the root. You would just set it equal to 0 and solve for x, and that's pretty easy. But we need to be able to find the roots. We've been talking a lot about how many roots these functions have, and now that we're moving on to more difficult functions, we need to be able to say, well, not only does this f of x function have two roots, but we need to figure out what they are as well. A couple other things that this function has. It's got a y-intercept at y equals 6, of course, right, because of that. It's this that determines the number of roots. That also determines how many times the function bends. And we know from last lesson that because this is an even function and it's positive, it looks like this. On the ends, that's what the end behavior would be. I don't know how many times it wiggles in the middle, but it does go upward in both directions. So we could say that our end behavior is as x approaches negative infinity, which is to the left, our function increases, and as x approaches infinity, f of x is also approaching infinity. All right, that's a lot of stuff that we can tell about this function without even graphing it. I just know from looking at the equation. But what we're going to focus on now is these roots. We want to find these roots. I know there are two, but I want to know what they are. And I'm sure you guys have used this method in the past. It's called double bubble. So what we're going to do to start, and we'll make a list of what our steps are. The key to double bubble is we can only use it anytime our a value is equal to 1. Let me explain what I mean by our a value. Every function that is a quadratic has an a that represents the constant in front of the x squared. It has a b that represents the constant in front of the x to the first. And it has a c which represents the constant on the end of the function. Okay, so if a, which in this case is 1, is equal to 1, then we can use this double bubble method. So we've got a few steps, and I'm just going to list them here. I would pause this video and write down those 4 steps. So what we're going to do is, to start, we'll set our function equal to 0. All right, so our function is x squared plus 5x plus 6, and instead of calling it f of x, let's set this whole thing equal to 0 right now. So that's step 1. Step 2 is to find two numbers that multiply to c. Our c term in this function is 6, and that add to b. So what I usually do is I make a list of all the numbers that I know that multiply to 6. That could be 6 and 1, it could be negative 6 and negative 1, it could be 3 and 2, it could be negative 3 and negative 2. But what I want to find out now is which of these pairs, if I add them, will also give me 5. 6 plus 1 is 7. That's out. Negative 6 plus negative 1 is negative 7. That's out. 3 plus 2 is 5. That's the one I want. Okay? So I've done that. I've found two numbers that multiply to c and add to b. And those numbers are 3 and 2. Now step 3 is that I'm going to use those numbers to write the factors of f of x. Factors look like this. And our factors are going to say x plus or x minus whatever our factors are. So our first factor is going to be x plus 3 because one of our factors is 3. Our second factor is going to be x plus 2 because another one of our factors is positive 2. So those are our factors of f of x. And I know that these are factors because if I multiply them together using FOIL, I'll end up with the original function. And now the last thing is to solve each factor. So if we're going to say that this times this equals 0 for some x value, that means that we've got to figure out what x value would make this factor 0 and what x value would make this factor 0. So I'm going to set them each equal to 0 and then solve them. Which means our roots are negative 3 and negative 2. So that's great and all, but the reality is most of the time our function is not going to have an a value that's equal to 1. It might be a -1, it might be a 2, it might be a -5, whatever it is. If this is not a 1, we can't use this very basic double bubble method. So we have to kind of expand this method and make it just a little bit more involved. So for a function like g of x, a is not 1. So we're going to have to use this new set of steps. Okay, again, I would pause the video and write down these steps because some of them are new. The first step is the same. Just set it equal to 0. 2x squared minus 3x minus 2 equals 0. Okay, but step 2 says to find two numbers that multiply to whatever a times c is. Well, if my a is 2 and my c is -2, then that means I need to find two numbers that multiply to -4 and add to -3. So that could be -4 and 1, 4 and -1, 2 and -2. Those are all my factors of -4. So if I start adding them, I'm going to find that I get that -3 with my first two pairs. So I've done the first two steps. Now it says to rewrite b as the sum of those two numbers. So this is where it gets a little tricky. This b term, we're going to rewrite it now. Instead of writing -3x, we're going to write -4x plus 1x. Because we decided that -4 and 1, if I add those, are the same as -3. So I'm replacing this -3 with these two terms. And I can't forget that I also still have the -2x squared and the -2. So all I've done is get rid of this and replace it with this. That's all I've done there. Okay, so that's the major step in this process, is that replacement. So now that I've done that, I'm going to group and factor the first two terms, so that's those, and the last two terms, that's these. It's a subtraction sign. So I've grouped them, and now I'm going to factor them. What can I pull out of here? I think I could pull a 2 and an x, right? If I do 2x squared divided by 2x, that's going to just leave me with x. And if I do 4x divided by 2x, that's just going to leave me with a 2. Over here, there's nothing that I can pull out of these, so I just have to leave it as x minus 2. That's also a step we're going to have to practice. 5 says to factor the common binomial out of this whole expression. So now, this is another factoring step. Let's pretend this whole thing is what we're trying to remove pieces from. And this addition sign here is kind of creating a divider between the two things that we're factoring. What could I pull out of this term that this term also has? And you got to think big picture. They both have an x minus 2. So I can take that x minus 2 out, just like I did in the last step. Take that x minus 2 out. And when the x minus 2 comes out, because I just factored it out, what am I left with inside? Well, I'm left with a 2x. And over here, don't forget, if I do x minus 2 divided by x minus 2, I get 1. So I'm left with 2x plus 1. And this is probably something we're going to need to practice a lot in class. So I would watch this through a couple times so that you can see this process. But now we're left with two factors, just like how we were left with two factors above, right? Two factors, two factors. These aren't as nice as these two factors, but I can still solve them. I can set x minus 2 equal to 0. I can set 2x plus 1 equal to 0, and then I can solve. Okay, so in the end, I do still have my two roots. My roots are -1/2 and 2. And the reason that those didn't factor very nicely was because one of my roots was a fraction, so I had to use this process. Okay? The last thing, and we're going to talk about this a little bit in class, is if this doesn't work, if you can't find two numbers that multiply to this and add to your b term, you have to use the quadratic formula. So I'm just going to write it here and finish the video with that. I'll write the quadratic formula below. You should have it in your notes. It should be something you've seen before, but I don't think you've probably memorized it yet. So here's the quadratic formula. And if you ever can't find numbers that multiply to c times a and add to b, you can use this quadratic formula, and we will use it in class at least one time tomorrow. But mainly, we're going to be focused on this piece tomorrow. We're going to practice this stuff a lot, all right? So if it was confusing to you, I would watch it through one more time and make sure that you see where all this came from. But we are going to practice this tomorrow in class.